This could well be one of the best training grounds for climate change of anywhere in the Pacific. The corals on Ofu Island in American Samoa are some of the strongest corals we know of. They're resistant to heat and light to a degree that most of the rest of the corals in the Pacific can't match. These lagoon reefs heat up at the low tides of summertime, so much so that the corals are exposed to quite high temperatures. But they're still alive, they're still growing, they're still thriving. That was the first clue that told us that these corals might, in fact, be strong. The corals here are exercised by low tides and the high temperatures. And as they experience those high temperatures, they become tougher and tougher. By experiencing this high temperature periodically and then relaxing, and then doing it again and relaxing, that kind of exercise regime might make them stronger and stronger and stronger. They can actually survive even more stress than these lagoons hit them. We know that by doing experiments on these corals, and perhaps that extra strength will be really important when global climate change raises the temperature all over the Pacific of reefs, threatening them with extinction.
What we have here are 8 individual tanks. They each have a pump that creates a lot of flow inside.
So these are like robot tide pools. We have the cool pool here, like pool 400, the normal temperature one. This is the hot pool, like pool 300. We control the temperature precisely. We have 4 replicates of the cool and 4 replicates of the warm, and we can set up to test whether the corals that are out there now are strong enough to take the temperatures that are normally seen in the warm pool.
So these 4 tanks will be set for a control temperature, an ambient temperature, maybe 29 degrees C, and the 4 tanks behind me will be set to go to a high stressful temperature of 33 degrees Celsius.
And by taking corals from out there on the reef and bringing them here, testing them at 2 different temperatures, we can see how they react to those temperatures.
So the specific challenges of this system were that it needed to be really small enough that we could bring it here on a small plane, but big enough that the corals would live, have enough flow that the corals would live, and we have to be able to control those 2 temperatures I was talking about.
Now the hot pool is so hot that it usually causes an enormous amount of stress in most corals, but these corals are strong enough to take it.
One of the great things is that these 4 tanks, which are supposed to all be the same, are all the same, like to the 10th of the degree. They match each other, and then they're within a 10th or 2 of our target.
And that's how we prove that, by moving them in to these little robot tide pools and seeing how they do when we give them 6 hours of high temperature. It's like a treadmill test, only with temperature that we're exposing these corals to.